Hello, my name is Langarudi. I'm a research assistant professor at New Mexico State University. The work I'm presenting was part of my dissertation under supervision of Professor Mike Radzicki at Worcester Polytechnic Institute. This work will be published soon by Springer as a chapter of a book called Feedback Economics, as referenced here. In this research, we address this question that if natural resource wealth is a curse or blessing for a nation. This is an important question because it impacts development strategies of nations that rely on commodity exports. A wrong answer to this question could fundamentally change development patterns of those nations. Resource curse hypothesis is a very old idea. 16th century philosopher Jean Bodin believed that nations with greater natural resource wealth tend to be lazy and less productive than those without such wealth. In 1950s, Raoul Prebisch and Hans Singer independently observed that commodity prices tend to grow slower than the average price of other products. Based on this observation, they predicted that nations that rely heavily on commodity exports would perform worse than others in the long run. The natural resource curse hypothesis was not formalized until 1990s when Sachs and Warner introduced their famous observation, which is shown here. Basically, the idea is that there is a negative correlation between natural resource endowment, measured by share of resource exports and GDP, versus growth rate of real GDP per capita. More recent studies, however, have cast doubt on this hypothesis. The conflicting results are usually due to differences in methods or data. So the question is still open that if the resource curse is real or not. More important than that is to know if the so-called curse depends on the specifics of the social, political, or economic structure of a system. To answer these questions, we have developed a model that takes into account all the potential causes of natural resource curse, including Dutch disease, which is the industrialization due to addiction to imports, temporary loss in learning by doing, corruption, the boom and bust cycles associated with commodity prices, rent-seeking behavior, sociopolitical turmoil, and or armed conflict over natural resource revenues, and bad policies such as overborrowing or overly generous transfer payments to citizens, and so on. So we developed a comprehensive model that incorporates all these theories. It has all the important sectors that play a role in shaping a potential natural resource curse. To formulate the model, we have used previous resource-based economic development models such as Mashaykhi's and Moxness dissertation models. The soft aspects of the work came from Khalid Said's models, for example, farmers, bandits, soldiers, generic structure, and our own models of Cartesian theory of arbitrary state and society. In this model, the natural resource revenues represented by the oil sector is an exogenous driver, as you can see here. This sector, the oil sector, is specified exogenously so that we could run control experiments related to natural resource exploitation. 4 export scenarios are evaluated to cover almost all general modes of behavior that may occur for the long-term stream of resource revenues in a real-world situation. These scenarios are designed in a way that total accumulated revenues by the end of the simulation is exactly the same for all scenarios. In other words, the only difference between these scenarios is their dynamic behavior and not the magnitude of the revenues. To measure aggregate impact of export scenarios under uncertainty, we formulate a social utility measure that included many aspects of development as listed here. Therefore, our definition of the curse is much more comprehensive than what we have seen before in the literature. W here represents the weight of each of these factors in the social utility measure. These weights are randomly changed in our Monte Carlo simulations so that societies with different sociopolitical agenda could be simulated. All the factors are normalized by their initial values too. We also defined rho as a relative measure to compare different resource export simulation cases with their counterpart non-export or non-oil cases. Here UZ is accumulated social utility in a zero export scenario, while UO represents the accumulated social utility in an oil export scenario or resource export scenario. Positive values of rho imply a blessing, while we can interpret the negative values as curse or burden. To determine the effects stemming from natural resource exploitation, we perform Monte Carlo simulations on each of the export scenarios that I explained before. These experiments are performed under a normal institutional settings as listed here. This histogram shows the frequency of simulation runs that yield a certain value of rho. Remember that negative rho indicates a curse situation, while positive rho means blessing. As we see, only a small percentage of simulation runs generate a negative rho. The highest number is 1.5%, which is for the cyclical scenario. The results of the first set of experiments were achieved with a normal or good institutional setting, as I explained before. Many economists, however, believe that initial institutional conditions have a significant effect on whether the endowment is a blessing or burden. To test this hypothesis, a second set of experiments were conducted on the model with relatively bad institutional setting. This was achieved by starting the model with lower productive forces, greater levels of corruption and illegal activities, and a lower number of good institutions relative to the base run. From this box plot, we can see that majority of the simulation runs again yield a total social utility greater than the no oil scenario, thus calling the curse hypothesis into question again. This time, the highest probability of the curse is for the bell-shaped case at 13.6%. This is in line with the findings of Robinson et al., who claimed that a temporary flow of natural resource revenue is worse for a nation than a permanent flow. Previous experiments were run with initial oil revenue set to 40% of initial GDP. So what will happen if this initial condition is varied? So we tested this problem, and here is the result. For all four export cases, we see a positive correlation between oil revenues and social utility, which indicates a blessing rather than a curse. Also, we see a decreasing marginal social utility from increased resource revenue, which is interesting. We saw that resource revenues are unlikely to harm a society, but is there a way to improve their impact? To answer this question, we explored the model and its potential leverage points. The first leverage we discovered was the amount of wage stickiness in the labor market. Here we see the results when wage stickiness is allowed to vary between 0 and 80%. We can see that in all cases, greater stickiness are associated with higher social utility. This implies that wage stabilization may enhance natural resource-based economic development. A deeper analysis of the results uncovered several powerful feedback processes at work, as shown here. A flow of oil revenue or resource revenue enables the government to increase its investment and hence public sector employment. Additional employment with stable or increased wage rates means a higher standard of living for the working class. This in turn leads to a higher participation in civil activities and an increase in the development of good institutions. More good institutions mean less chaos and corruption in the system, while an increasing wage rate reduces the incentives for parasitic behavior such as rent seeking. Lower chaos and corruption then encourages private sector investment, which generates even more employment and higher wages. Finally, lower levels of chaos and corruption free the government to spend more on public investment, so that closes the loop. Another leverage point uncovered in our study is social mobility, which is defined as the speed at which people change their socioeconomic status. As shown here, there is a significant inverse relationship between social mobility delay and social welfare. The reason is that in this case, the productive forces in the system spend less time in suboptimal states when people can change their social status and be more productive. The third leverage point discovered involves routing of some of the oil revenues to the private sector. We can see a mixed and surprising result here. A smaller fraction of oil revenue allocated to the private sector have a positive relationship with social welfare, but larger fractions allocated to the private sector have an inverse relationship with social welfare. So there exists an optimum level of privatization of oil exports that societies could seek to maximize their social welfare. An interesting point is that these results were obtained with the bad institutional setting. With the good institutional settings, however, the privatization has no meaningful effect. Why? We found out that the additional revenue strengthens the private sector and generates greater civil activities, more good institutions, and so forth, which generates added social welfare. However, once a revenue fraction threshold is passed, then the parasitic behaviors like rent seeking and corruption dominate and reduce social welfare. These dynamics cannot occur in a good institutional setting because the government is stronger and state control is more efficient due to lower corruption. To summarize, our comprehensive simulations could not support the natural resource curse hypothesis. However, they reveal the situations under which the curse might have a chance to occur. We also saw that resource export scenarios add to the social utility, but additional units of revenues added less and less to total utility. Finally, we showed that there are some policies that could be exercised to improve the developmental outcomes of resource experts. Okay, that's it. Here we have all the references cited. Thank you very much, and see you later.